Okay, welcome to everybody. So can you try question 1, please? Welcome, guys. Hello, guys. Yeah, if you're just joining us, we are doing question 1 on sheet number 10. Okay, so hello, good morning, guys.
Hello.
Hi. All right, so if you haven't done, if you have done it, it's fine, but if you haven't done it, let me show you how to do question 1, okay? So give me a sec. Okay, okay, all right, guys. So let me start with question number 1. All right, so the first part of question 1 is, all right, what you're given is the following. You're given a confidence interval for P, which is of the form that, of the following form, that is P hat minus Z 1 minus alpha by 2 times the standard error, which is P times 1 minus P divided by N. Right, this is the lower limit of the confidence interval. The upper limit is P hat plus the same thing, okay? Okay. Now the first part of the question is to find the width of the confidence interval. Remember, the width is simply the upper limit minus the lower limit, right? So in this case, the width will be 2 multiplied by this, right? Okay, guys, so you should take, I mean, it's obvious, like you should take the difference between the upper limit and the lower limit. This is what you get, and clearly this is proportional. This is proportional to this, right? Because 2 is a constant, and Z 1 minus alpha by 2 is also a constant. So therefore this is proportional. So that's basically part 1. Now part 2 of question 1 is about the function v of p equal to p times 1 minus p. So it's basically asking you to asking you to draw the graph of this function. I'm sure in semester 1, you must have done how to draw a graph of a function. You must have done many examples, so you probably know how to do this. So the first thing to do is to take the derivative, which is the derivative with respect to p is 1 minus 2p, and you set that to 0, and then you solve for p, so you get p equal to a half. Okay, now to see if this point is a maximum or a minimum, you take the second order derivative, right, which is minus 2, which is a negative number, right? So what this implies is that it implies that p equal to half corresponds to a maximum, I mean to a point of maximum, all right? And in fact, if you put p equal to half into the function v, you get half times half, which is a quarter. Okay. And if you put p equal to 0 into the function, you get 0. And if you put p equal to 1 into the function, you get 0. All right, so this is all you need in order to be able to graph the function. This is all the information that you need, right? So let's see how we can graph it. So that's part 3 of question 1. Is asking you to graph. It's asking you to graph the function, which I'm sure you know I'm very bad in drawing graphs. So sorry. Let me try my best. So this is suppose this is the p-axis. Suppose this is p of p. Suppose this is 0. Suppose this is 1. Okay. So according to the calculations we did, the graph is 0 at 0, 0 at 1, and quarter at the point half. So your graph must look like this. You follow me? So it's a maximum. It takes the value, its largest value when p is a half, and it takes the value 0 at 0 and 0 at 1. So this is the graph of v of p versus p. Okay, guys, are you with me or not? Any questions? Just use the chat box or talk to me using your microphone. All right, so that's part 3. Part 4 is about finding the upper bound for the width. Now we already know the width. The width is equal to 2 times this times this is the width. Okay, guys, and so using the graph, we know that p times 1 minus p is less than or equal to a quarter. So that means this must be less than or equal to okay. Now the square root of 4 is 2, so they cancel out. So this becomes z 1 minus alpha by 2 times 1 over root of n. Okay. Now let's put alpha. We are told 95%. That means alpha is 0.05. So 1 minus alpha by 2 is 0.975. Divided by n is 1000. So that is n is this. All right. So if you read this off the table, you will get is 1.96 divided by 1000. Okay. All right, guys. So this is the solution to question number 1 from sheet 10. Any questions you have? Is that all clear or not? If it's not, just please use the chat box, please. You guys okay?
Yes, it's all good.
Thank you, guys. Can you do question 3, please? Question 3. Let's go back to the sheet. So let me close this and let's go back to. All right, this is the sheet. Okay, can you guys do question number 3 now, which is over here? Question number 3 on sheet 10. Okay, guys. If you haven't done it, or if you have done it, either way, let me show you how to do question 3. Okay. So here we are. Share screen. So this is excuse me. This is question number 3. So you have two estimators. The first one is mu hat equal to n times x bar plus m times y bar divided by n plus m. Okay, and we are asked to show that this is an unbiased estimator for mu. So remember, what you need to show is that the bias. You need to show that the bias of the estimator is 0. So that's what I'm going to do now. So the bias is defined as the expectation minus the parameter that you're trying to estimate. So this is expectation of m x bar plus m y bar divided by n plus m minus mu. Okay. And if you take the expectation inside, you get n over n plus m times the expectation of x bar plus m over n plus m times the expectation of y bar minus mu. So this is n over n plus m times the expectation of x bar is simply the average of the x's. Okay, and the same thing for the second term. Okay. All right, guys. Now taking the expectation inside the brackets, and you get the following. You get 1 over n plus m, because the n's cancel, times the sum I from 1 to n of the expectation of xi. All right, and the m's cancel, so you get 1 over n plus m times the sum I from 1 to m of the expectation of yi. Okay. Now we know that the population mean is mu for both the x and the y's. So this is gonna be this, right? And the sum of the mu's is n mu divided by n plus m. And sum of the mu's on the second term is m mu divided by n plus m minus mu. And this is clearly equal to 0, right? Hence mu hat is unbiased for mu. All right, guys, is this okay with all of you now? Any questions on this, guys? All right, so this is only the first of the two estimators. The second estimator is for sigma squared, which is given as equal to n minus 1 Sx squared. Sx squared is a sample variance for the x's. M minus 1 times sy squared is a sample variance for the y, divided by n plus m minus 2. Okay. Now, if you sub in the formulas for the sample variance, you can write this as follows. I'm sure you know the formulas for the sample variance. So subbing it for Sx squared, you get this. Because all right, so this is the estimator that you're given, and we want to show that this estimator is unbiased for sigma squared. So once again, we need to find the bias and show that it is equal to 0. Okay. So taking the expectation, get 1 over n plus n minus 2. In brackets, you have expectation of the sum. So I'm taking the expectation inside the square brackets, as you can see. Okay. Then you have the expectation of minus sigma squared. Okay. You guys with me? And then, okay, now I'm going to do a trick. I'm going to apply a trick that we learned in the class long time ago. Now what I'm going to do is I'm going to multiply the outside term by sigma squared, right? And because I have multiplied by sigma squared, I need to divide also by sigma squared. So that's what I'm going to do here. Right? Okay, guys, you with me? Now, the next thing is that you may recall from some time ago that before the Easter break, I discussed something called the chi-square distribution. And one of the properties I mentioned in the class is that if the data are normally distributed, then the thing inside the brackets has, okay, let me write it down. The thing inside the brackets has a chi-square distribution with n minus 1 degree of freedom. This is something I mentioned way back a long time ago. It sounds like a long time now. So if you know where this comes from, I will write it down in just a minute. Using properties of chi-square distribution, which we talked about in the class. Okay, so you need to look back in the notes, either the printed notes or the scan notes. Both of them contain the result that I'm talking about here, right? Okay. All right. Now, next step is now the one property of a chi-squared variable is that the expected value is equal to the degree of freedom. So the expected value of chi-squared n minus 1 is n minus 1, and similarly is m minus 1. So, all right, and this is clearly equal to 0. So hence, we can conclude that the estimator is unbiased for sigma squared. All right, so that's only the first part of question 3. The second part of question 3 is to find the variance. Is to find the variance of mu hat. So part 2 of question 3 is to find the variance of mu hat, right? So the variance is, okay, let me go back to the question. Okay, so the variance is simply the variance of n x bar plus m y bar divided by n plus m. Okay. Now, if you take the variance inside the brackets, you need to remember to square all the constants. So this becomes okay, this becomes this, and okay, plus m squared okay, guys. Now, taking the variance inside the brackets, you can see it's going to be n squared going to be this, right? Plus m 1 over m squared variance of yi. Okay, guys. Now we know from the question that the variance of all the data are sigma squared. So this reduces to, by the way, these two guys cancel. So these two guys cancel each other. So you get 1 over n plus m squared times the sum of sigma squared, right? That's the first term. And the second term is 1 over times the sum of sigma squared, right? So what you get is n sigma squared plus m sigma squared divided by n plus m squared, right? Which is equal to, excuse me, it's equal to sigma squared divided by n plus m. Okay. So this is the expression for the variance of mu hat, and clearly this approaches 0 as n approaches infinity, or m approaches infinity, or both. Okay, okay guys, so that completes question number 3. No, it's a long question, but I hope you followed what I did. Or is there any questions you have? Hello guys.
No questions. No.
Okay. Can you do now question 5, please? Question 5. So let me go back to the sheet. Question sheet. Okay, question 5. This is question 5 is over here. This one. Yeah. Can you do that, please? Okay, guys. Had you done question 5, guys, or not yet? Okay, let me show you. I know we're running out of time now. So, but let me show you quickly how to do question 5.
Brand B. For each patient, the response recorded was the time, in minutes, for the drug to reach a specific concentration in the bloodstream, giving the following results. Brand A, N1 equals 12, X1 equals 21.8, S1 equals 8.7. Brand B, N2 equals 12, X2 equals 18.9, S2 equals 7.5. Assuming that the absorption times for the two brands are normally distributed with a common but unknown value of 2, and the 95% condense interval for 1, 2. The mean difference in absorption times between brands and B
question 5,
conclusions.
right?
5. A random sample of N1 equals 288 voters registered in the U.S. state of California, of which 141 voted in the last presidential election. From a random sample of N2 equals 216 registered voters in the U.S. state of Colorado, 125 voted in the last presidential election. Construct an approximate 95% condense interval for the difference in the proportions voting in California and Colorado at the last presidential election. Can you conclude whether the population proportions are the same or different? 2.
All right, let PX denote the proportion voting in the presidential election in California, and PY denote the proportion voting in the presidential election in Colorado. So CA for California, and CO for Colorado. So what we want is we want to construct a 95% confidence interval. So, and if you look at the nodes, the 95% confidence interval for the difference in the proportions, which is I gave you in the notes some time ago, is something like this: is x bar, sorry, excuse me, x bar minus y bar. I will explain what these are in a minute. X bar is a sample proportion for the first population, y bar is a sample proportion for the second, then z1 minus alpha by 2, and then in brackets you have these numbers. N1 is the sample size for the first population, and N2 is the sample size for the second population. Right. So this is the formula. It is in the notes I gave you, both the scan notes and the printed notes. Now let's see what is given to us. What is given to us is the following: N1 is equal to 288. N2 is equal to 141. X bar is the sample proportion for the first population, which is 141 out of 288. And Y bar is the sample proportion for the second population is 125 out of 216. Sorry, is it? Am I right? Yeah, sorry, I made a mistake here. It should be 216, not. This should be not 141. It should be 216. So it's 125 divided by 216. All right. And alpha is 0.05. So Z or Z 0.975 is equal to 1.96. So this is all the data that we have. So all you have to do is just sub them into the formula. Hence the 95% confidence interval is as follows. So it's 100 141 divided by 288 minus 125 divided by 216 plus or minus 1.96 in square root, in a big square root sign, x bar, which is 141 divided by 288, 1 minus divided by n1, which is 288, plus y bar is 125 divided by 216, 125, excuse me, writing is getting worse all the time. There's 125 divided by 216 divided by 216. All right, so this is the 95% CI, and if you work it out, I mean, if you have a calculator, you can work it out. I don't have one, but I will check the solutions in a sec. Where am I? Just a minute. I'm trying to see the solution. Okay, the solution for this confidence interval is as follows. Is minus 0.177 comma minus 0.0015. So this is the 95% confidence, which is clearly negative. So what this implies is that that px minus py is possibly less than 0. So in other words, the proportion voting for presidential election in California is less than the proportion voting for presidential election in Colorado, right? Okay, guys, so that's question number 5. So there are 2 questions I haven't done today, but you can check the solutions online, on the course website. I'm sure you know where it is. Next week, by the way, next week we will do revision classes, because we have I will send an email to you guys later today. We have completed the syllabus for the course as of yesterday. So next week will be revision classes, although there will be no final exams. The purpose of the revision classes is just to reinforce everything that you learned during the semester, during the whole semester. So any questions you have or you can think of, please bring them for the classes next week. So we will have regular classes next week as usual, but we will do just revision problems only. Okay. Okay, guys, have a good day, and thank you, everybody, and have a good day, and take care of yourself wherever you are. Okay. I will see you.
Thank you.
Yeah,
thank you very much.
Yeah, pleasure. And
thank you so much, sir.
Yeah, pleasure. Any questions, just 24/7, all right? Email me or Zoom me. Okay. Hello, Chris. Are you okay? Do you have the mic working now or no? I said the next week the lectures will be revision classes, Chris. So we will not have no more lectures, but during the lecture times we will do revision problems. Like I will go through maybe like the past exam paper questions or something like that. So there won't be. The lectures will be turned into revision. Right. Yeah. Yeah, that's what I mean. So now, yeah. I mean, time. I mean, call me. It would be good to talk to you by phone or mic later on.